Good morning and welcome back to Kennedy Space Center for today's pre-launch briefing for the Orion flight test, which is now less than 24 hours away. It's our last chance to get a good rundown on what the plan is for tomorrow, so we've got a good lineup for you here. We're going to start with Mark Geyer, who is the Orion Program Manager for NASA. He'll be followed by Mike Halls, who is the Lockheed Martin Orion Program Manager. Then we'll go to JSC to talk with Mike Serafin, who is the Orion Flight Director. Then come back here to hear from Jeff Angermeyer, the Ground Systems Development and Operations Program Mission Manager for the flight test. After that, Ron Fortson from United Launch Alliance. He's the Director of Mission Management. And we'll wrap up with Kathy Winters, who is the U.S. Air Force 45th Space Wing Launch Weather Officer. We'll start again with opening remarks from each of them and then take questions. Mark?
Okay, thanks, Brandy. Well, thanks everybody for coming. Big day for us tomorrow, less than 24 hours, as Brandy mentioned. I know many of you got a chance to go out to see the rocket and Orion today. I got a chance to do that yesterday. We got to get up close. They wouldn't let me touch it. I got close, but they wouldn't let me touch it. But when I look at it, it reminds me of when I look at each part, it reminds me of the decisions we made as a team. It reminds me of the thousands of people that have been a part of Orion, that have been part of making this hardware come to reality. And it's going to be a great day for us tomorrow. It's the beginning of exploring beyond low Earth orbit, and Orion is a key piece of that. I did want to remind people that this is important. It's a test flight. The great thing about EFT-1 is it's unmanned, and so we are pushing on the systems to make sure they work as we expect. We have great models on the ground, a lot of, I'd say, some of the best experts in the world on space systems, but still when you put something into hardware and actually fly it, we need to make sure that it works right before we put people in it. So we're pushing on those systems, heat shield, parachutes and other things, to do just that, to learn how this vehicle behaves in the environments in deep space. So those were the key parts I wanted to mention. We did have an MMT. The mission management team met today, the L-1 MMT, where we went over the specifics of how things are going. I know Mike Serafin will talk about landing weather, and Kathy will talk about the launch weather here for tomorrow, so let them go over that. But all that is looking good too. But on the vehicle side, everything is extremely clean. The paper's done. We have one very small issue with some ground equipment that lets us initialize some of the DFI, but none of those are launch commit criteria issues. So we're ready to go. So I'll pass on to Mike.
Great, thanks, Mark. So I guess my theme today is partnerships and the teamwork. So it's a real privilege to lead the Lockheed Martin team and all of our subcontractors, suppliers across the country, some 46 states of folks across the country that have put this spacecraft together that we're getting ready to fly. Mark stressed the test flight aspect of it, and you've heard me the last couple of days mention that this is kind of a test flight of the ways that we work together as well. This has been a unique contracting mechanism. NASA has tasked Lockheed to actually procure the launch vehicle and work with ULA and deliver the data as a product at the end of the test flight. So we have a lot of unique partnerships in this. Even though we're putting the flight together, we're using Jeff and his team in terms of all the recovery activities. Mike and his team is our flight control team. We do not have a unique Lockheed flight control team. We have engineering support both here and out in Denver to provide support to the mission, but we're really making the best use of this blended team that helps us do this very effectively. And it's been a great partnership with NASA, with ULA, and it's great to be here at this point. From an MMT standpoint, we have folks coming in close to midnight tonight to get on console and get ready so that we actually power Orion up about 6 hours prior to launch. So we'll be there in time to follow along with the spacecraft power up and then to follow along with the ULA team as they go through fueling and all of those actions to get ready for launch. And with that, where do I turn it, Brandy?
We're going next to Mike Serafin, who is at Johnson Space Center. Mike? Johnson Space Center. Mike?
Yeah, good morning. I'm Mike Serafin. I'm the lead flight director, and I'll be with my team in Mission Control here in Houston tomorrow for the in-flight portion of the mission from liftoff through splashdown, overseeing Orion. I want to echo a few of the comments that Mr. Geyer and Mr. Hawes just said. I'm really happy to be here today. There's a lot of work by a lot of team members on the Orion team and the United Launch Alliance and the U.S. Navy and NASA team that got us here today. And put us in a posture to fly tomorrow. I was reminded by my boss yesterday to take a moment and sit back and reflect on where we are and all the work that's gone into this. I tend to be very focused on moving forward and just kind of task-oriented, get the job done. And I did that yesterday. And what struck me the most was we have clocks in Mission Control, and the clock was 1 day and change and counting. And coming over here to this press conference, the launch window open is less than 24 hours away, and it's just a great time to be here. And the team is ready. We had a conversation in Mission Control with the team yesterday about what it was feeling like, what the tempo and the mood was, and we haven't had this feeling in a while, since the end of the shuttle program, launching an American spacecraft from American soil and beginning something new, in this case exploring deep space. And while the feeling is familiar and the anticipation of day of flight is familiar, it's a new mission, and there are some things that I'm sure we're going to learn tomorrow from this unmanned flight test that'll enable us to fly humans into deep space. So those are kind of my thoughts on where we are today. I do want to just review the mission profile and the mission timeline, and we've got a few graphics to show that in terms of our orbit track that we're planning on flying. Again, we're going to fly 2 orbits. The first orbit is a low Earth orbit, roughly the same altitude that the International Space Station flies. The second orbit is a high Earth orbit, and we'll get up to 3,600 statute miles above the Earth. In terms of ground track and trajectory, it is a due east launch out of Launch Complex 37, launching on the Delta IV Heavy off Space Launch Complex 37. That'll take us out over the Atlantic Ocean, where we'll achieve orbital insertion, and then we'll cross the southern tip of Africa. We'll complete our first lap, and then once we get an hour and roughly 2 hours into the mission, 120 minutes mission elapsed time, we'll do our orbit raise burn, and that'll set up that high Earth orbit in the apogee of 3,600 miles. That will lead up to the splashdown off the coast of the Pacific, and we'll have a guided entry from entry interface to the ground for Orion. The upper stage will actually stay mated to the service module and do a destructive reentry over the Pacific and come down far away from Orion, north of the Hawaiian Islands. In terms of just the general mission timeline, we've got a brief video to show you again, just to kind of remind you of the mission profile. So we'll power up the launch vehicle and the spacecraft. The launch vehicle will get fueled, and then at roughly 6:05 Central Time, launch window open. We plan to lift off. The Delta IV Heavy will take us to orbit using 3 liquid core boosters. Just shy of 4 minutes into the mission, the core on the left and the right will separate, and the center core will continue on till about 5.5 minutes mission elapsed time. Then it'll shut down and separate from the upper stage. The upper stage engine will ignite, and the service module aerodynamic fairings and panels will separate, and then we'll jettison the launch abort system. Orion will then continue its climb to orbit. In roughly 17 minutes into the mission, we'll achieve orbital insertion, and Orion will begin its first lap around the Earth, again in a low Earth orbit. At around 120 minutes mission elapsed time, the second stage will ignite again, setting up that high Earth orbit in the apogee and the entry interface point. All the while, we'll be doing a barbecue roll for thermal conditioning, rotating about the long axis. When we get to the high Earth orbit portion will pass through the Van Allen radiation belts on the way up as well as on the way back, where we could see some effects on our flight computers and various avionics. And then we'll get a great shot of Mother Earth from 3,600 miles up. We'll return on the return side, and 3 hours, 24 minutes into the mission, Orion will separate from the service module in the upper stage. The reaction control system will activate, reorient the heat shield forward, and then Orion begins its trial by fire. It'll decelerate from 20,000 miles an hour at an altitude of 75 miles to zero velocity at splashdown in just 11 short minutes. Once we get past the peak heating period, we'll jettison the forward bay cover, which is a thermal cover for the parachutes, and then we'll begin the parachute deploy sequence. And Orion will start to drift down, go through its parachute deploy sequence, ultimately ending up with the 3 main parachutes deploying. They will slowly unfurl to provide a measured deceleration of the spacecraft leading up to splashdown. Upon splashdown, we'll keep the spacecraft powered up for a period of time because we expect a portion of the heat from that reentry, the plasma outside the heat shield, will reach 4,000 degrees. We expect some of that to soak back into the vehicle structure, and we'll keep the spacecraft powered up for a period of time to understand that thermal effect and how hot it gets in the cabin before we put our astronauts on board. If necessary, the crew module uprighting system will upright the spacecraft, otherwise the bags will just inflate, and we'll keep the spacecraft powered up for about an hour after splashdown to gather that thermal data. After we've reviewed the data, I'll call the NASA Recovery Director, Jeremy Graber, on the USS Anchorage and let him know the health and status of the spacecraft. And once we've cleared the vehicle of any hazards, the recovery team will come in and attach some tending lines and a tow line to the Orion capsule. And then it'll begin the team will begin the recovery of Orion by towing it into the well deck of the recovery ship. It's, again, a very, very exciting time to be here. The team in Mission Control is ready. The ground systems are ready. The spacecraft and the launch vehicle are ready, and it's feeling like it's time to go fly. In terms of the landing weather out at the splashdown zone, our weather forecaster, Tim Garner, has given us a good forecast for the splashdown and recovery location. We're not expecting to have any weather-related violations of our launch commit criteria at the splashdown zone. The wave heights at the sea state will be roughly 3, and the wave height will be about 5.5 to 6 feet, which are favorable conditions to recover the spacecraft. So with that, I will pass it over to Jeff Angermeyer, who will talk about the recovery operations.
All right, good morning and welcome to the Kennedy Space Center. I'm pleased to report that the Ground Systems Development and Operations Program from the Kennedy Space Center is ready to recover Orion once it splashes down in the Pacific Ocean. In concert with Lockheed Martin and Orion program, we partnered with the United States Navy to facilitate recovery. Our recovery ships, 2 of them departed Naval Base San Diego Monday afternoon. The USS Anchorage is on site in the landing zone, which is approximately 600 miles southwest of San Diego. The USNS Salvor is on the way to the site. It should be there later this afternoon. To prepare for recovery, we had our team out on the west coast in San Diego, loading the ships the week prior to Thanksgiving. I do have a couple of charts up here, a couple of pictures I'd like to show you, highlight some of the activities. This is a picture of the two recovery ships. The Salvor is in the background, and the Anchorage is in the foreground. The advantage of the Anchorage in the foreground is, as you can see on the left side of the picture, it has a flight deck that we can use for helicopter landings. Underneath the flight deck is the well deck, and that is the place where we'll flood it with water, and that's what we'll use to pull the Orion crew module into the ship. Also from the Anchorage, we have 6 small boats that will deploy, 4 rigid hull inflatable boats and 2 Zodiac boats, and those will be the folks that will have the people on board that will go out and actually do the recovery of the flight hardware. So in the background is the Salvar. It is a smaller ship. It's about 250 feet long, but don't let the size fool you. It's a very capable ship. It serves as the backup ship for our recovery. If for some reason we can't recover the crew module into the well deck ship, we'll be able to crane the crew module out of the water and onto the aft deck of the Salvar. So it is backup for a crew module recovery, but it is primed for recovering the forward bay cover. That is as Mike mentioned, that it provides the heat shield protection for the parachutes, and the Salvar also recover the parachutes. Next picture, please. This shows us loading the Salvar. You can see on the deck there's a white structure there. That's the cradle. That if we were to load the crew module onto the Salvar, it would be placed on that and secured for the trip back to San Diego. Suspended from the crane, being lowered down on the deck, is our tire and fender assembly. During the recovery operation, that'll be draped over the side of the ship. So as we pull the flight hardware on board the ship, it won't bang on the side and it won't damage the flight hardware. Next slide, please. This is inside the well deck. This is what we call the crew module recovery cradle. This will be the structure that once we recover, we'll place the crew module in this carrier assembly, and that's what we'll use to take the crew module off the ship once we get back to San Diego. In the background, you can see a forklift bringing one of our multiple logistics containers onto the ship. We have lots of spare parts in case we have any issues with the equipment while we're out at sea. Next picture, please. This shows another picture of the well deck, looking from the back end of the ship towards the front end, almost in configuration for recovery. Of note, at the front part, you'll see some black stripes on the floor of the well deck. Those are about a foot in diameter. They're what we call the speed bumps, and those provide a soft cushioning. So once we get the crew module into the back of the ship, we will place it onto those speed bumps and drain the well deck and do all the securing that we need to do for the spacecraft. Next page. This is the anchorage departing San Diego on Monday. Of note on the back, as you can see, the stern gate is closed. Those doors in the back end of the ship, they will open, and that is where we'll let the Zodiacs will deploy out of that location, and that's the location where we'll pull the crew module in. And I think I have one more picture. And once the ships got underway, the helicopters took off, and they landed on the flight deck of the anchorage. We have 3 helicopters on board, 2 prime and 1 backup, and they're there to provide imagery during descent and also provide assistance during recovery. The helicopters will be the first on the scene. They'll drop smoke and help to identify where the crew module is, the parachutes and the forward bay covers. Then the 6 small boats will go off and begin the recovery process. Right, so with that, from a recovery perspective, we break this into 3 phases. First phase being the pre-launch phase, which basically goes from now until T0 of launch. Then we get into the mission phase, which is about 4.5 hours long, and then we have the recovery phase, which will take about 6 hours from splashdown until we have all the equipment into the ships and we're heading back. So what I'm going to do is highlight a couple of the milestones and things that we'll be doing during those 3 phases to facilitate recovery. So today we're going to deploy the first of a series of weather balloons. The weather balloons will feed the data into the flight control team, so we'll get a good sense of the weather at the landing site. We'll also perform some communication checks between the ships and the Mission Control Center in Houston. We're going to perform some just-in-time training today. We're going to take the 6 small boats, put in the water, get the people on the boats comfortable in the environment, one last chance to review their procedures prior to the actual activity on Thursday. We're also going to flood the well deck of the ship. We're going to help to characterize the environment in the ship. We're going to make sure all the equipment we have on board is ready to go. And we'll also, by flooding the well deck, that allows the Zodiac boats to be deployed. Last thing we're going to do today is we're also going to have let the helicopters take off, go do a practice run on their mission profile to ensure that the 2 helicopters are ready to go. Getting into pre-launch tomorrow morning. About 4 hours prior to launch, the ships will be positioned in what we call the hold zone. It's about 10.8 nautical miles outside the actual splashdown point. They will stay there until later in the count. About 2.5 hours prior to liftoff, our NASA recovery director, Jeremy Graber, who's on the anchorage, He will report on station and give the mission management team a status of the ship's readiness. And the full recovery team, their day really begins about 4.5 hours after launch. And like I said, it's about 6 hours of work they have, so we're letting them sleep prior, just up to liftoff. And so at liftoff, the full recovery team will be awake on the ships and starting getting ready for the recovery. So that's the first phase. The second phase from the mission, once we lift off, again, it's 4.5 hours mission elapsed time. About 3 hours and 45 minutes prior to that, we'll have call to stations. Basically what we'll do is we got our integrated procedures. We'll get those started, and it basically gives the guidance and the control for all the activities we'll sequence throughout the recovery operation. About an hour and a half prior to the recovery, we'll deploy the rigid hull inflatable boats. The 4 boats, they'll be craned off the side of the anchorage and put in the water. An hour prior to splashdown, the helos will take off, and also we'll be given the go to reposition the 2 large ships and the 4 small boats that are in the water at that point a little bit closer to the landing zone. We'll be about 5 nautical miles about an hour prior to splashdown. Ultimately, at splashdown, we should be as close as about 3 nautical miles with the ships and the assets ready to facilitate recovery. And so once it splashes down, then we get into our third phase, the recovery phase. At that point, we lower the stern gate and we allow the Zodiacs with the divers to deploy from the back end of the ship. At that point, the small boats will go off and start to locate the crew module. They'll look for the forward bay cover and the parachutes. The parachutes we plan to have on board the salvor, starting to crane them out of the water about an hour after splashdown, and the forward bay cover should be recovered onto the back of the salvor about an hour and a half after splashdown. As Mike mentioned earlier, the spacecraft will be powered up for about an hour after splashdown. So our team on the Zodiacs, they'll station keep about 100 yards or so away from the spacecraft. Once it's powered down and it gets turned over from the flight team to the ground team, the team will then do a slow approach, do a safety assessment to make sure it's safe to approach the spacecraft. Once we get the all clear, the first step we'll do a detailed photo survey. We're going to take lots of pictures and imagery of the top of the spacecraft. We'll also have divers taking high definition imagery of the heat shield from underneath. Once that's complete, then we'll start the process of recovering it. We have what's known as a horse collar assembly that attaches. We will drape that around the base of the Orion crew module. What that allows us to do is attach the winch line onto the horse collar, and that's what we use to pull the spacecraft in from the ocean into the back of the well deck ship. We'll also shoot tending lines out to it. We'll have a series of tending lines attached to it, so as it's approaching the ship, we'll have crews on the side of the ship that'll help control it as it comes in to maintain good control of it as it comes into the well deck. Once we get inside the well deck, we'll position it over the speed bumps from the pictures I showed you earlier. We'll drain the water out, and it'll rest down onto the speed bumps, and that should be about 4.5 hours after splashdown. And finally, once we have the crew module safed and the well deck water drained out, with the small boats, we'll get them back onto the ship, and that should be at about 6 hour point after splashdown. At that point, we'll start heading back to Naval Base San Diego. On the way back to San Diego on Saturday, as we're getting closer, we'll again flood the well deck. We will reposition the crew module from the speed bumps, and we'll position it into the crew module recovery cradle. That way, it will be ready once we get to San Diego to be offloaded. The arrival at San Diego is planned for Sunday of both ships, and our plan is to have have Orion back home at Kennedy Space Center a few days before Christmas. So with that, it's been over 40 years, close to 40 years since NASA's recovered a human-rated spacecraft from the ocean. So I want to commend the team that has worked many years to get us to this point. It's an exciting time. You can feel the buzz on the center. Everyone's excited to go do this operation. And from our perspective, the team is ready, and we're excited to be a part of the journey that's taking the next steps to Mars. And so with that, I will hand it off to Ron.
Thank you very much. So once again, as I mentioned yesterday, United Launch Alliance is extremely proud to be a part of the NASA's Orion spacecraft mission. Yesterday, I talked a little bit about the processing that we accomplished in leading up to where we are today. And today, I wanted to show you a brief video of the sequence of events that's going to occur once we lift off until we separate the the crew module. So if you didn't catch everything in the first video, hopefully you'll be able to see some of those events again. So if we could show that video, please.
The following profile details the important events of this mission using approximate times.
5, 4, 3. And the RS-68 engines roar to life and liftoff of the United Launch Alliance Delta IV.
3 RS-68 first-stage engines ignite to lift the vehicle away from the pad. Shortly after liftoff, the Delta IV begins its initial pitch and yaw maneuvers to attain the proper ascent profile. At 82 seconds, the vehicle experiences maximum dynamic pressure. The Delta IV is now traveling at Mach 1, the speed of sound. At 3 minutes 53 seconds, the port and starboard CBCs are throttled down. 3 seconds later, the strap-on CBC engines are shut down. At 3 minutes 58 seconds, the port and starboard CBCs are jettisoned. The center CBC is immediately throttled to full power to maximize performance. Approaching main engine cutoff, the Delta IV is burning propellant at a rate of 1,050 pounds per second and flying at more than 90 miles in altitude, 365 miles downrange, and traveling at a speed of more than 13,474 miles per hour. Main engine cutoff occurs at 5 minutes 31 seconds. 7 seconds after main engine cutoff, the first stage is jettisoned. Ignition of the second stage engine takes place 13 seconds after stage separation. At 6 minutes 16 seconds, the service module fairing is jettisoned, followed by jettison of the launch abort system at 6 minutes 21 seconds. The first cutoff of the second stage engine occurs at 17 minutes and 17 seconds into the flight. The mission now enters an extended coast phase, lasting approximately 1 hour and 38 minutes. At 1 hour 55 minutes, the second stage engine is restarted for a short second and final burn. The burn will last approximately 5 minutes. Cutoff of the second stage engine occurs at just over 2 hours. The mission now enters a final coast period in preparation for Orion separation. The coast phase will last 1 hour 23 minutes. At 3 hours 23 minutes, the Orion spacecraft is delivered to orbit for Lockheed Martin and NASA.
So as far as the activity that's going on now, this morning it's actually fairly quiet. We pretty much got the vehicle buttoned up and ready to go, and the crew is resting for the day, and they'll be coming on console a little later today. Starting in the evening, we're going to be prepping for the move of the mobile service tower, which will occur around 11 p.m. tonight. Once we get the service tower back, the remaining crew will be coming on console in the Delta Operations Center, and they'll be doing all the final activities and fueling the rocket and getting ready to go for launch Thursday morning. So at this point, we're ready to go, and if all goes well, we'll be executing what you just saw in the video tomorrow morning. So once again, it's been a great team effort. ULA is very proud to be part of this team and to work with a lot of great individuals and great people to continue to pursue human space flight exploration. So once again, thank you very much, and I'll turn it over to Kathy Winters to let us know how the weather's going to be.
Well, right now the weather forecast actually improved today. We're in an easterly flow pattern here in Florida. We have high pressure that's been persistent to the north, just high pressure areas just passing by to the north, and that puts us in an east wind, and we've been in that pretty persistently all week. When we have that kind of weather pattern, we tend to get coastal showers in the area, and we also tend to get gusty winds. Gusty onshore winds. And so those are mainly our primary concerns for tomorrow morning as well. Now the moisture tends to wax and wane during this period. So yesterday we had a lot of coastal showers in the area, but things have really dried out today and the weather's really nice outside. We expect it to stay dry through the day today, and then as we get into the launch tomorrow morning, we are going to start seeing an increase in moisture, but probably not enough that's going to cause a significant concern. So I did lower the number. I had forecast a 40% chance of LCC violation yesterday and the day before, but today I actually lowered that number to 30% because of the drier atmosphere. It does look like moisture will increase as we get into Friday, so I kept the Friday probability of violating launch commit criteria for weather at 40%. But things are starting to look more favorable for tomorrow. So if you look at, I'm going to go ahead and have a satellite picture shown. You can see generally we have just a nice benign weather pattern, if you will, no significant fronts moving through the area, very mild temperatures, and we have an easterly wind flow over Florida in the lower levels. That tends to bring in cumulus clouds and coastal showers in from offshore, kind of on and off as the week has gone by. We expect that to be the main concerns as we go into the launch window and the following day as well. So go ahead and I'll bring up my launch forecast here. You can see we are expecting just scattered skies. I changed that yesterday. I was thinking that was going to be a ceiling, but I do think it's going to be more scattered now in the low clouds, so hopefully you'll be able to see the launch real well. Scattered at 3,000 feet, and then a ceiling at about 25,000 feet. We do expect some high clouds to come in a little bit tomorrow, but again, not a concern for launch commit criteria violation. Visibility will be unrestricted, and temperature should be right around 72 degrees, nice and mild for launch, with winds from the northeast from 60 degrees, 10 peaking to 16 knots. And that's a little bit lower forecast than what I had been forecasting the last couple days, and that's, again, we think the gradients can be just a little bit looser tomorrow. So overall, the main concerns will be isolated showers that could be in the area. And so our primary concerns for launch are flight through precipitation, which is a vehicle-specific rule, and also liftoff winds. We are not concerned about any of the triggered lightning launch commit criteria for tomorrow morning. We do have a 30% chance of violating one of those two constraints for launch. If we do happen to delay 24 hours, you can see the forecast is not much different. I do, though, bring in a ceiling at 3,000 feet on the forecast. We are expecting a little bit more moisture, a little bit more cloud cover. The pattern's generally the same, but I think there's going to be an increase in coastal showers due to just more moisture in the atmosphere. So with that, there's a 40% chance of violating the launch commit criteria. I also think the winds are going to be a little bit gustier. So the primary concerns are flight through precipitation and the liftoff wind. So overall, right now things are starting to look real promising for tomorrow. Another thing that's good to know is the type of weather pattern we have. If we did have a violation, there tends to be breaks in this type of weather. So with the longer launch window, it looks pretty promising weather-wise for launch.
Okay, great news. So we are going to start taking questions here in the room. A reminder to state your name and affiliation before your question, and also to address your question to who you want to answer it. And remember that Mike Serafin is at Johnson Space Center, able to answer questions there as well. So we'll start over here.
Marcia Dunn, Associated Press, probably for Mr. Geyer or anyone else who would like to address this. From where you sit at this point today, do you see tomorrow's flight as on a par with the first steps of Apollo, perhaps the first flights of the shuttle? Can you sort of put that in comparison? And since there are no people on board, does that sort of take an edge off the tension for tomorrow?
Yeah, great question. So I think it is, in the sense that we are beginning a new mission, it is, I think, consistent with those, the beginning of shuttle, beginning of Apollo. It's a new mission for us, starting in the region of the moon and then beyond. So I think it's in that same category. Certainly the team is excited at that level. We're going to learn a lot on this flight. It does help that this is unmanned. It's important it's unmanned because we actually structured the test to fly the riskiest pieces of the flight. This is the time to do it when it's unmanned. And so we intend to stress the systems and make sure they behave as we designed them to, or as we modeled it. So that is really important, an emphasis. It is a test flight, and it's set up to be a risky flight, to learn those kind of things. So it is different when you have people on board. Yeah.
Hi, Clara Moskowitz with Scientific American, and this is a question for Mr. Angermeyer. Can you talk in a little bit more detail about the process of getting the recovered capsule back from San Diego? What kind of vehicles, what kind of roads?
We have a detailed transportation plan. We have to file permits with the Department of Transportation. They give us a route to transport it back from San Diego. After we offload it from the ship, we have about 2 days of activities to prepare it, or some safing we need to do, and we also load it on the back of an oversized flatbed, it departs sometime on Sunday. Is the current plan. While it's coming across the country, we have a constant purge on the vehicle, so that we can maintain it in the best condition possible when it gets back here. So it takes anywhere from 10 to 14 days to get across the country. And like I said, we expect it to be here a few days prior to Christmas.
Philip Sloss with NASASpaceflight.com. I think this is for Mr. Fortson. If you have a hold or a cutoff during terminal count tomorrow, how long would it take to recycle to be ready to pick up again? And is there any, would that be a spacecraft or a launch vehicle being the long pole in terms of doing a recycle?
Well, it really will depend on what the reason for the delay is. Typically, we can turn the vehicle around, assuming there's no significant issue. Say it was an issue with the range or something like that, we could turn it around in 15 to 20 minutes. So that's normally what it take. But that actually depends on when the hold is called, and that really determines how long it will take us. But on average, it'd be 15, 20 minutes to turn it around.
I'm Alan Boyle with NBC News. Maybe for Jeff, I just was hoping to get a little more information about what sorts of imagery we might see in real time. Are we going to be able to see what the divers see? Will there be pictures available, or is this something that we'll be seeing later?
I can answer some of that, but I think maybe our public affairs folks could give you what's coming real time. A lot of the imagery that we're taking from the helicopters and from our folks on the small boats, that's not going to be broadcast live. We do have a drone that's going to be providing live video feed. I don't know if you want to talk a little bit more about that.
An unmanned aircraft called a Nakana is what we're hoping to use to get some video of the crew module coming down under parachutes. That does depend a little bit on the weather, so hopefully that will cooperate. But hopefully we'll be able to get you some good views of that. As far as the recovery operations, once they get started, that will be probably coming after the mission.
James Dean with Florida Today. First question for Jeff. I was just curious if you could maybe compare how similar your recovery effort is to what they did in Apollo, and is anyone with Apollo experience actually on the team or advising you in any way? And similarly for Mike Seraphin, I was just wondering about the composition of your mission control team. Is this, as Bob Cabana referenced earlier today, like the band getting back together, all veteran shuttle folks, or is it a totally different, a different mix of people that's working this mission?
Okay. Let's see. I'll answer your second question first. Yes, we did have some folks from Apollo that we have been assisting us. We sought their guidance on how they did things during Apollo. We actually have, one gentleman was on some of our underway recovery tests, some of the practice runs that we've made over the last 6 months, and I believe he's also out on the ship with us at this point. As far as the differences between what we're doing, what Apollo did, Apollo, the capsule splashed down and the astronauts got out, and they were hoisted, I guess, from a basket up into a helicopter and brought on board the aircraft carrier. That was for a lot of the trips to the moon for the Skylab flights. The astronauts actually stayed in because of the long duration aspect of that mission. They stayed in it, and a human-rated crane lifted them onto the deck of an aircraft carrier. For us, for this mission, it's some of the things that we're doing. We're definitely going to inform whenever it becomes a manned spacecraft later in for EM2. So we're learning some things that we're going to apply to the EM2, but as we started to develop our concept of operations, we knew that one of the priorities for this was to maintain the integrity of the heat shield, to get as much data back to Lockheed Martin and Orion as possible. And so with that, we're taking a more controlled approach and how we're doing during recovery. Like I said, it takes about 4.5 hours for us to get this crew module pulled into the well deck. So difference between Apollo is the capsule was lifted out of the water onto a flight deck. For this, the intent is if the astronauts are coming back in the EM1 long term, we would like to keep them in the spacecraft, and the best solution at this point we're targeting is the well deck up. For this one, it's about 4.5 hours. We know our requirement when crew is on board to have the crew module recover within 2 hours. And so after EFT-1, we're going to do a detailed lessons learned review, look at our concept of operations, and work on some improvements to ensure we can meet that to our requirements. So.
Okay, let's let Mike Seraphin take a shot at the other question.
Yeah, in terms of mission control, we are going to have an Apollo veteran is one of our VIPs in mission control. Gene Kranz is planning to come and view the flight test of Orion here tomorrow with us. So I look forward to very much to having him watch the team in action. As far as the composition of the team, there is a little bit of a sense of getting the band back together, as you said. The blended team of Lockheed Martin and NASA personnel that are supporting the mission from in-mission control are all shuttle veterans, myself included. I've worked with each and every one of these people on space shuttle missions in the past. So when I was first introduced to the team about 3 years ago, when we started planning and preparing for this mission, I just had a big smile on my face because I knew every single one of those people, and I knew what they brought to the team, and it's a good feeling to be to have that amount of experience, trained operators and people that know how to fly spacecraft and do it to the level of precision that these folks do, and to just watch them prepare for the mission. We've trained together, and we're ready to go fly tomorrow.
Okay, back here for questions.
Jay Barbary with NBC. I have a two-parter. Run for you when the second stage of the Delta IV Heavy cuts off for the final time. Will it, in this way out orbit, be up from 17,003 to 20,000 miles per hour, maintain that until it comes back in for reentry? And then I have one for Mike out in JSC. Well, Mike, I'll go ahead and ask you. The president has already been set on Apollo 8, the first Apollo to go to the moon. It was manned. The first all-up space shuttle was manned, and I know several of the astronauts would like to see this flight coming up in figure 8 around the moon in 2018. They want it manned. Any chance of that?
Well, I'll answer the manned question because it's really a program question with engineering and safety, right? So the EM1 plan today, Jay, is it involves, first of all, adding additional key parts to the service module, which we're not flying on this flight, and is the absolute first flight of the rocket. So in Apollo 8, that was not the first flight of the full rocket, right? So that's important to know. In shuttle case, we flew the shuttle with crew because we really had no other option, if you remember. The shuttle could not fly itself. So in this case, we have the option. We will have full abort capability, but in this, that's really the key, Jay, is we're looking at that flight. We believe it is more prudent to fly an unmanned version on the first time on the rocket and all the way out to the moon to check the systems out. There's also, for Orion, based on the funding, the budget funding, I won't have all the crew systems done by EM1, right? I won't have the displays, I won't have all the ECLS, and my full qualification is not complete. That's a budget-driven thing. So that would have to change first on EM1, and then we would have to change our look at what risks we were willing to take. But it is a good question because we need to do that in every flight, right? We're going to have the same discussion on that, yeah. So, but you had another question on the flight itself.
Right. So as far as the second stage, after we deliver the crew module where it needs to be, we're going to do a collision contamination avoidance maneuver to make sure we get away from it, because we're going to be about 3,125 nautical miles in altitude at that point. So we'll do that collision avoidance maneuver, make sure we're out of the way of the crew module. At that point, we're already on a trajectory that's, normally the mission we fly, we have a perigee altitude that's positive. In this case, it's actually negative because we're going to be bringing it in a controlled environment. So we'll do another burn about 15 minutes later. That'll pretty much get in a controlled deorbit, and we'll bring it in about 20 minutes later, around 4 hours after the flight. It's going to splash down in the Pacific Ocean, just north of Hawaii and Midway, right in that region. So
that's about 20,000 miles an hour.
It's going to be coming in pretty. I don't know specifically how hot it's coming, but it's going to be coming in pretty fast. Yeah.
Thank you.
You're welcome.
Hi, it's Bill Harwood, CBS News, and this is for, I guess, Mark or Mike. Can you guys give me a sense of what the margin is if some of the separation events don't occur for whatever reason? For example, if you didn't get all three of the panels off of the service module, or if the LAS didn't let go, or one or more parachutes fails to deploy, that kind of a thing. Can you discuss all of those mission-ending events, or can you still get a mission out of some of those, and how that works?
You want to take that?
No. Okay.
Well, we've done a test, or we haven't done tests. We've done the analysis of if the last didn't separate. That's an extra 16,000 pounds, and we can make it to orbit, but without the last off, you don't have parachutes. You don't, so you're certainly not going to get anything out of the reentry stage of that. So each of those kind of has a different scenario to it, Bill, in terms of how it would impact. But clearly, the big separation events are a major part of this test, and that's one of the big things that we're trying to demonstrate.
Parachutes are a little bit different. We're designed to land with just 2 parachutes. So if we failed one of the mains, we're still designed to land successfully. So if we lost one of the drogues, it's going to affect our entry speed. So it would depend on when, what the failure was as to what kind of loads we'd get on the pilots and the mains. But parachute failures were a little more resilient too.
Craig Cavalt with Aerospace America, and I have 2 questions, one of them flight side, one of them ground side. If you have an accident with the Delta IV tomorrow morning, is there any way possible to SEP the spacecraft, or is it no way to get it down on chutes under any failure mode on the Delta?
We decided when we were looking at flight test objectives, which we looked at the most critical and where we had the money to spend on it, we decided not to put a full abort system in on this flight because it would have required a full abort motor, that 500,000-pound solid rocket motor, an attitude control motor, and all the other guidance needed. And so we decided not to spend the money on that because of the extremely low likelihood of an accident, and we spent that money on other objectives. So on this flight, we're not going to be testing the abort system. Yeah. Yes.
And the second question. Thank you. Could you go into more detail on how you're going to study the heat shield and the timing of that? Will you take plugs, for example, or are you going to totally disassemble it as the first primary thing you do? Just play that through the next several weeks or months.
So obviously there's a lot of this, the DFI instrumentation, the developmental flight instrumentation that's associated with the heat shield, both the avcoat material itself, the composite back shell, the titanium skeleton that's under it. So there's a lot of instrumentation that goes with that integrated structure. We're looking now at taking some plug samples just post-recovery when we get back to dock in San Diego, and the team's formulating that plan as we speak. But then once we truck it here back to Kennedy, we're looking at one of the first things that happens is removing that heat shield, so that it then goes off to other NASA sites for further testing and evaluation. And all that DFI data, Craig, the plan is we will actually get into the capsule on dock and pull out the data recorders and actually go and process those right now at a Lockheed Martin facility on the West Coast, so that we can get data as quickly as we can to the teams.
My name is James Tutton. I'm a Spaceflight Insider, and my question is for Mr. Angermeyer. I believe they said that the wave height was 3 to 5 feet during splashdown. Is there a limit to the wave height that would not allow you to use the well deck on the first ship, or you have to use the crane on the second?
During our practice runs, both ships came in at about, our recovery procedures came in at about the same height. The Salver maybe has just a little bit more capability with dealing with worse weather. But the conditions we saw for our last underway recovery test, we were working in swells of 5 to 8 feet, and it was choppy with periods as low as 4 to 8 seconds. And so what we have for this recovery right now is we're hearing 6 feet, a little bit less, so it's within our experience base. And with the wave periods of about 11 seconds, we're feeling real comfortable we'll be able to get the job done.
Jane Wells, CNBC. Mark and Mike, I don't know who this is for, but it's kind of an odd question.
It's for Mike then.
I'm sure everything is a closed system as much as it can be, but in this new environment we live in, not like the shuttle days or Apollo, where there's cybersecurity really is the issue, security is the issue, and hacking is happening so much. Have you had to approach this differently to maintain security in a way you haven't had to before?
Our human spaceflight experience is operated under significant security in terms of the command links and the data links. So actually, Mike Serafin and his team have already loaded encryption onto the spacecraft, which we would use for any of our programs. So we do take that very seriously. We've tested all the ground links and the flight links. We've tested our links to the TDRS satellites for our data. So that's part of our normal way of doing business, actually. And Mike might comment more from the flight control side.
I don't have a whole lot more to add to that. Obviously, the data link with the spacecraft is encrypted, and we've got precautionary measures put in place for that. The data here on the ground, we have firewalls in place, and we know exactly who the data is getting to, and the personnel are restricted in terms of number and location. So there's a number of precautions put in place to not only manage the link with the spacecraft, but once it gets here, who gets it and who gets to see it.
Okay. Johnson, I'm with the German press agency. It was clear, I think, to the world that under the Apollo launches, there was a competition, there was a space race, it was first to the moon. And I'm just wondering if that's part of the message now, if it's a race to Mars, and if there's a message here for other countries that are going to Mars, and if this is a successful test flight, if that puts the United States ahead of the other countries.
I think so. I think it's important for the United States to lead in space exploration, but in leading doesn't mean you go by yourself. And I think the space station is the best example of that. United States is the key provider, and we integrate all these other countries that are experts in going to space, including ESA, for example, is the best example. So Orion is the beginning of that for exploration, in that ESA is providing key parts of the service module for our next flight. So to me, that's just more evidence that when we go to these deep space destinations and onto Mars, we're not going to go by ourselves. We need but it's important for the United States to lead, and Orion is the beginning of that.
Thank you, Tarek Malik with Space.com. I have I think a short two-part one for Mike Serafin. Mike, you mentioned how good it was that to kind of feel that you're doing something new again, yet the gang is all back together. And I'm wondering tomorrow at Call the Stations, what you're going to tell the team to say, we've got this thing to do. It's completely new, and here's how we have to make focus. What will you tell them to keep everyone on track and yet excited for the test? And then, just as part two, how are you going to celebrate? Is there a party, champagne, baked beans? Just wondering. Thanks.
Thanks for the question, Tarek. So I've already told the team that we've spent a lot of time understanding the spacecraft, testing it, building all the operations products and ground systems and displays and tools in mission control, and interfacing with our engineering counterparts to make sure that we understand, to the best of our ability, the vehicle and the systems. And that we've done all of our prep, and we've tested ourselves, not only in terms of vehicle testing and developing the ground systems, but also in terms of training. We've integrated with the broader team at the Cape, the launch vehicle team, the pre-launch team, the recovery team, through a series of events that have kind of taken incremental steps leading up to today. And every single one of those steps we've learned stuff, and we've applied those lessons learned. And that's the best that you can do. We all know what our role is tomorrow, and those roles are defined clearly. And the team has been tested in a number of ways, and it's just time to get on with flying. And I have full confidence in the team. Again, these are veteran operators, and we're ready to go fly tomorrow. In terms of post-flight, yes, we are going to have a splashdown party, and we'll just take a moment together as a team and have a little food and drink, and just after our shift is over and after we've handed over to the recovery forces, just reflect on what we've accomplished and what's ahead of us.
Aviation Week, for Mike or Mark, to follow up on Craig's question, what telemetry data are you going to get down just in case, God forbid, you should lose the capsule and won't have access to that recorded data? And how quickly would you be able to use that data?
So we have operational instrumentation separate from the DFI instrumentation that gives us the state of the spacecraft systems. And that's actually what Mike's team in Houston is operating on through the whole time. The spacecraft is designed to be largely self-controlled. So the software is flying the mission. But Mike's team has gone through, and we have identified a number of commands and flight rules and protocols between Mike's team and our mission management team for how we utilize those capabilities to do any kind of those recovery actions during the mission, Frank. And we'll be watching those. Well, Mike's team will be watching those very clearly, working with both the NASA and Lockheed engineering teams to make sure that we understand the ramifications of any change of configuration. But we have a whole series of flight rules that enable Mike's team to go in and do much of that work just as they respond to the anomalies.
Okay, over here.
Jason Ryan with spaceflightinsider.com. We've talked a lot about heat shields. I'd like to talk a bit about the chutes. Orion has, I believe, 11 of them for future crew-rated versions. And I think this is probably from Mark and maybe from Mike, and I have a follow-up. With the addition of crew accommodations and environmental systems, is the weight that Orion will have in that configuration sustainable for the chute systems that you guys have planned for it?
Yeah, Jason, that's a great question. The crew module weight is what the crew module can weigh is really driven by the parachute size and actually the heat shield thickness. Both of those are affected if you get too heavy, if you get heavier. So those are actually our bounding limits, is really the weight under the chutes. So mass is critical in general, pushing it to the moon, because we require an upper stage and more prop right if we get heavier, but we also have that limiting case where we've got to be not heavier than the chutes can handle. So that's been the limit we've been using, that we have designed EFT-1 to, and then more importantly for EM2, because we're going to add all the other stuff, all the crew and everything else. The EM1, EM2 design now accommodates what we've learned on EM1, or excuse me, on EFT-1, and will meet the mass targets that are driven by the parachute capacity. And so, for example, we've done a lot to reduce the mass between EFT-1 and now the manned flights, and the barrel, the pressure barrel, which is, if you remember the crew module when it was at the Cape when it first showed up, the green structure, there's a barrel section around the middle. That is one of the heaviest elements of Orion. And the barrel for EM1 is in manufacture in Southern California today, and it's 25% lighter than the one we're going to fly on Thursday. But that's a great question. That's a limit. We got to meet it, and we've already got designs now in place that we're working on EM1 to make that work.
I reported on NASA's spaceflight.com that I think the first crewed mission will take place to 2024, and I think the last time that you and I spoke, it was 2021. Can you talk a little bit
about where they got that number? It's 2021 is our plan for EM2.
So it's still 2021?
Yes, sir.
Thank you very much.
Yeah.
Take one over here.
Hi, I'm George Pontual from Globo, Brazil. I'm covering the story of a 13-year-old called Alyssa Carson. Since she was 5, she decided she was going to be the first person on Mars. She's very determined. She's preparing. She's here for the launch. What I would like to ask each of you, what say to her, to Alyssa? Maybe give up, go get a life, or come join us. Whatever you want to say, please.
I would say come join us. I guess I'm probably the oldest guy here, so it's the experiences that I've had. I came into just before shuttle flew, while many of the Apollo veterans were still at NASA. And the ability to learn from those teams and then see this whole transition through space station to now getting back to deep space has just been phenomenal. And so I would clearly say come join us.
Anyone else want to say something to Alyssa?
Yeah, I'll speak. She definitely needs to come join us. We know that if we're going to when we go to Mars in the 2030s, she'll be of the ripe age to come out here and help us do what we're trying to do. International flavor that Mark talked about earlier. It's great to get young people interested in what we're doing here. I think working in the space business, at least for me, made many ways it doesn't feel like a job coming to work every day. It's wonderful what we do. It's very fulfilling, and just to experience that, I think she'd really enjoy being a part of the space program.
Would you
say something?
I just think it's amazing, and I just hope she keeps pushing towards that dream. And yes, definitely come join us and study your math and science. And you know, even if you hit a roadblock, push right through it, because everybody does. And don't let it stop you. Don't let anything stop you.
Okay, we're going to take 2 more questions. First over here, and then one back there.
Sawyer Rosenstein with Talking Space. This is for Mike Serafin over in Johnson. I was wondering exactly what point Mission Control takes over on the mission and what your role is going to be, whether it's monitoring or if you have the ability in a contingency to take over control of the vehicle.
Okay, that's a good question. We have 2 objectives that we're going to support in terms of flight test objectives during the mission that we're going to nominally go after. The launch abort system jettison video that's recorded during the launch phase. We will downlink that once we get to orbit, and we've got some commands that we're going to send in real time to do that. And then that post-landing power down, we're going to issue a command to extend that from 15 minutes to an hour after splashdown. If we do nothing, the vehicle's going to power itself down at 15 minutes. But if the performance margins, the cooling, the battery power, all that is looking good on the spacecraft, and we get into the second orbit, we'll send a command from the ground to extend that power down. That's on the nominal day, assuming everything goes well. Those are the things that we'll do, and then the rest is just sit back and watch some amazing video of Earth from high altitude and watch the health and status of Orion. We do have a bucket of tools available to us, some contingency commands that'll do things like update the navigation state vector, power cycle the global positioning system receiver. Any number of other things are available to us from the ground. If we see something go awry with the spacecraft, we're prepared to execute those. We hope that we don't need those. We're preparing for the worst and hoping for the best tomorrow.
Good morning. Back here in the back, Liz Hurley, WAFF Huntsville. I have 2 questions. One's logistical. As a girl who grew up in South Florida watching all of the Apollo missions, it was absolutely thrilling. You know, you could get up on your roof, you could watch from anywhere. Tomorrow with their trajectory, where will people be able to see this? Where up and down the coast can you see it, and how far to the west, given the the trajectory? My second question is, we've heard about the contributions. Mike Haas talked about it from the 46 different states. But from our vantage point, from top to bottom on this rocket, it looks like the state of Alabama has made significant contributions. Can you talk about that?
Yeah, I can speak to the Alabama part. If you look at the very tip, the launch abort system, the folks at Marshall Space Flight Center are the lead, or they're actually supporting the launch abort system oversight. In other words, they're the NASA guys who are part of understanding how the solid rocket motors work and how they're integrated, so they're key for that. The guys also made, within Marshall Space Flight Center, made a lot of parts for us, where we had some critical parts that we had suppliers that we couldn't get delivered on time. They actually made parts for us. There's a lot of suppliers within the Huntsville area that made key structures on this element. And then if you look at the Orion interface with the rocket is called the MPCV adapter. It's called the MSA. It's around the bottom. And actually that was built by the folks who are making SLS today. And that adapter will be exactly the same design that will fly on EM1. So up and down, there's a huge amount of contribution from the folks now. Of course, the rocket is made in Decatur. So, and I forgot your first question.
Second question, where can you see it?
Yeah, maybe Ron knows.
Yeah.
Yeah. Delta 4
Well, you should be able to, if you're anywhere on the coast, you'll see it. I mean, it's going to be heading kind of somewhat downrange, south direction. So, but in the morning, the sunlight coming up, it's you may see, you may have some little obscuration from the sun, but you should be able to see it from pretty much anywhere on the coast.
The coast? The East Coast?
East Coast, yeah. I think you should be able to see it from the East Coast.
Miami to New York?
It's hard to say.
Yeah, there may be some high clouds. That prevent a little bit of that.
I'm not sure what the weather is going to, but I mean, if it's clear.
The high clouds are in the area, but I know people that have seen it from Miami before. And
Yeah.
I don't know how far north.
Yeah. So.
Okay. I think we'll wrap up there. You want to stay tuned at here on NASA TV to check in on the NASA social that's going on. We're going to have some televised portions of that at 1 p.m. It'll be having participants from NASA centers across the country, and you'll get to hear a little bit more about Orion and some of NASA's other plans. And then, of course, obviously, tune in tomorrow. We'll start our coverage for the flight at 4:30 a.m. Eastern Time, and we'll stick with it through splashdown. So we'll see you tomorrow. Thanks.